Good day, everyone. So today we are going to be focusing on kinematics in two dimensions. So in our previous video, we've talked about what kinematics means. Kinematics simply means the study of motion without considering the force causing the motion. So now you have to know that after you have known the meaning of kinematics, you have to know that kinematics can be subdivided into two ways. We have the kinematics in one dimension, we have the kinematics in two dimensions. We are not talking about the kinematics in one dimension. We can further subclassify that into two other ways. So kinematics in one dimension can be subclassified into equation of body in a straight line or equation of body under gravity. So in our previous video, we've talked about equation of motion in a straight line and equation of motion under the influence of gravity. So today, we are going to be talking about kinematics in two dimensions. And kinematics in two dimensions is basically talking about projectile motion. So this simply means that whenever we are talking about projectile motion, we are going to be considering two dimensions. So the horizontal dimension and the what? Vertical dimension. So guys, what is a projectile? A projectile is an object or a body launched into the air and allowed to move on its own or moving under the influence of gravity. So a projectile is an object that is launched into the air and it is allowed to move on its own or under the influence of what? Gravity. So whenever you are talking about projectile motion, a projectile body moves in a parabolic manner. So you have to understand this, that a projectile body moves in a parabolic manner. So parabolic manner is just talking about a what? A parabola shape. And the paths taken by a projectile is called trajectory. So the paths in which a projectile body followed in a parabolic manner, that path is referred to as what? Trajectory. So by now you should know the difference between projectile and what? Trajectory. So some examples of projectile motion is what? A shot arrow, a thrown javelin, a fired bullet, a shot catapult, a thrown discus. So let's talk about the what? The classification, or let's talk about projectile motion in its two dimensions. That is, let us consider a projectile body moving in a parabolic manner. Now, considering the what? The horizontal direction and the what? Vertical direction. So guys, if you are talking about the projectile motion in two dimensions, so the two dimensions we are going to be considering will be the horizontal x-axis and the vertical x-axis. So this simply means that whenever an object is moving in a parabolic manner, this simply means that that object can be resolved in two dimensions, the horizontal and the what? Vertical. So when we are talking about the parabolic manner of a projectile, this is what we mean. Now, let's say initially we have an object here, and this object is launched into the space. So this object that is launched into the space is going to move in a parabolic manner like this. It's going to move like this and come back to this initial point. So this is what we mean by a parabolic manner. So whenever an object is moving in a parabolic manner, that object can be referred to as a what? Projectile motion. So an example is when is a fired bullet. When a bullet is fired up into the sky, it moves in a parabolic manner. A shot catapult also moves in a parabolic manner. So that is that, guys. So guys, you have to know that for this object to move in a parabolic manner, it has to start with a particular velocity known as what? Initial velocity. This simply means that initial velocity is what is the velocity that will be used to propel this object in a parabolic manner. So that is why we drew our initial velocity like this. This is u. This simply means that the object is moving by this initial velocity u. So since we are talking about a projectile motion that has two dimensions, this simply means that the initial velocity can be resolved into two dimensions. We can have the initial velocity for the vertical, we can have the initial velocity for the what? Horizontal. So this simply means that this initial velocity, since it is not moving in a straight line like this, it is not moving in a vertical direction like this, it is moving in a parabolic path like this. This simply means that it has a particular angle. This simply means that it has a particular angle. So that is why we put the angle here. So this angle theta simply means the angle of projection. That is the angle at which this projectile body is being projected. Do you get that? So therefore, that is why we put the angle theta here. So guys, listen attentively. You have to know that the angle of projection must always be to the horizontal. So if you are given a particular question and they say that the angle is to the vertical, so the first thing you should do is that convert that angle from vertical to what? Horizontal. The angle of projection must always be to the what? Horizontal. So that is that about that, guys. So this initial velocity is going to be resolved into two dimensions. What and what? Horizontal and what? Vertical. Don't forget that whenever we are talking about horizontal dimension, we are going to be talking about what? X-axis. Whenever you are talking about vertical direction, we are going to talk about what? Y-axis. This simply means that this initial velocity is going to be resolved to the horizontal axis. So that will be what? Ux. So this simply means that this u can be resolved to the vertical or to the horizontal. So if I should resolve this u to the horizontal, I'm going to refer it as what? Ux. But if I should resolve this to the vertical, I'm going to resolve it to the what? I'm going to write it as what? Uy. So that is that about that, guys. So this simply means that all the initial velocity, final velocity, and distance for a projectile motion, they can be resolved into what? Two dimensions. That is to say, the horizontal direction and the what? Vertical direction. Now let's talk about how they can be resolved into two dimensions. So guys, we are talking about resolving a projectile into the horizontal direction and the vertical direction. Before I move on, do not forget that in the last kinematic video we did, we talked about kinematics in one dimension, which can either be the equation of motion in a straight line or the equation of motion under the influence of gravity. And whenever we are talking about the equation of motion under the influence of gravity, that is if an object is either moving upward vertically or coming downward vertically. So I told you that whenever an object is moving under the influence of gravity, that is, whenever it is moving vertically, upward or downward, this simply means that it is under the force of gravity. And I said that force of gravity always acts vertically downward. Do you get that? So now, if an object is moving upward with an acceleration, and since it is moving upward with its own acceleration, the force of gravity always acts vertically downward. This simply means that that object is moving against the gravity. So we are going to say that the acceleration of an object moving upward against the gravity will be what? Will be negative, because it is moving against the gravity. But for an object that is moving downward, this simply means that its acceleration is moving due vertically through the what? Through the gravity. So the acceleration due to gravity for an object moving downward would be what? Positive. So you have to know that force of gravity only have effects on an object moving either vertically upward or vertically downward. So for an object moving in an horizontal direction, force of gravity, acceleration due to gravity G, has no effect. So this simply means that for horizontal direction, the horizontal direction is not affected by gravity G. So that is why for horizontal direction of a projectile body, the acceleration due to gravity G would be what? 0. But vertical direction will have vertical motion will be affected by gravity. So therefore, the acceleration due to gravity G will be what? Negative when the body is moving against the gravity. So guys, let me put this to you. When will an object be moving against the gravity? Is it when it is going up or when it is coming down? What's that? When it is going up. Thank you. So if an object is going up, that simply means that it is moving against the what? Gravity, because gravity always acts vertically downward. That's that, guys. So guys, you know that we are talking about the parameter of kinematics. We can have three. We can have initial velocity, final velocity, and what? And distance, right? So now this simply means that I can have my initial velocity to be resolved into two manner, the vertical and the horizontal. So that is why I can have initial horizontal velocity. My initial horizontal velocity is known as what? Ux. That is Ux. And the formula for Ux is what? U cos theta. I can also have initial vertical velocity. That one is what? Uy. And the formula for that one is what? U sin theta. Don't forget, U simply means initial velocity. X means horizontal. Y means vertical. So don't confuse them together. So we can also have the final horizontal velocity. Final horizontal velocity is what? Vx. Vx, and it will have the formula as what? U cos theta. This simply means that Ux and Vx, they have the same formula, which is what? U cos theta. But final vertical velocity will be what? Vy. And the formula for Vy is what? U sin theta minus gt. Someone will ask me that, why is it that initial horizontal velocity and final horizontal velocity has the same formula, but initial vertical velocity and final vertical velocity has different formula? The reason why is this: you know, we've already known that our initial horizontal velocity ux is u cos theta, our initial vertical velocity uy is what? U sin theta. So we are going to remember that initially, from our kinematics in one dimension, v is equals to what? U plus gt, right? V is equals to U plus GT. So this V is equals to U plus GT is the equation that we used to derive the formula for Vx and what? Vy. So I can draw something like this. So I can say that Vx is equals to Ux plus GT. But guys, remember that whenever I'm dealing with X, which is horizontal direction for a projectile body, the acceleration due to gravity is always 0, right? So this simply means that this Vx will now be equals to Ux plus what? 0t. So therefore, Vx is equals to what? Ux. And the formula for Ux is what? U sin theta. That's U sin theta. But for my Vy, this simply means that my Vy will just be equals to what? Uy plus gt, right? So if it is moving against the gravity, the g will be negative. So it can toss to what? Uy is equals to Vy is equals to Uy minus GT. So therefore, guys, my Vy cannot be equals to, since my Uy is originally U sin theta minus GT. So that is why the formula is like that. So note that whenever an object is moving in horizontal direction, it's not affected by what? Acceleration due to gravity. So lastly, the horizontal distance Sx is what? Ut cos theta. And the vertical distance Sy is what? Ut sin theta minus what? Half gt squared. So let's talk about the what? About the resultant. So guys, you have to know that since we have initial horizontal velocity, initial vertical velocity, we can also get our total resultants for initial velocities. So the total resultant for initial velocity will be u, and how much will be what? Square root ux squared plus uy squared. We can also get the total resultant for final velocity. That will be v is equals to square root vx squared plus vy squared. Total resultant for distance covered will be what? S, and that's equals to what? Square root sx squared plus sy squared. And the angle of projection theta, the formula is given as tan theta is equals to what? Uy over ux. So guys, let's look at a particular example to justify all this formula we've written above. So the example we are going to be looking into now is, if an arrow is fired with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal, calculate the following. So they can ask you to calculate any of these questions. It can be initial horizontal velocity or initial vertical velocity. It can be horizontal velocity after 2.5 seconds in air or vertical velocity after 2.5 seconds in air. It can be horizontal distance after 2.5 seconds in air. It can be vertical distance after 2.5 seconds in air. So we all know that initial horizontal velocity is ux, initial vertical velocity is uy. But what is this horizontal velocity after 2.5 seconds in air? This horizontal velocity after 2.5 seconds in air is just talking about the final velocity. That is, after an object has moved with an initial velocity, it's going to attain a final velocity. So that's the final velocity we are asked to look for. So we are going to write solution and write out the parameters. So from the beginning of the question, it was stated that it moves with a velocity of 40 meters per second. That is u. That u is the initial velocity that in which that object was used to start the motion. That is u is equal to 40 meters per second. The angle of projection is what? 30 degree. And you will see that that 30 degree was to the horizontal. If the angle was said to be to the vertical from the question, if the angle was 30 degree to the vertical from the question, we would have converted it back to the horizontal. By what? By minusing from what? 90. But since it is to the horizontal from the question, we don't need to what? To convert it. So in the question, we are looking for the following. We are looking for ux, we are looking for uy, we are looking for vx, we are looking for vy, we are looking for sx, and we are also looking for sy. So once you've known the parameter you are looking for, then write out the formula. These are the formulas that we are going to be using for each question. So these are the formulas we are going to be using for each question. Now let's start. So for the first question, ux, which is initial horizontal velocity, that will be equals to u cos theta. Since in the question our u is 40, that is 40 cos 30, and that gives us 34.64 meter per second. The second question is uy, initial vertical velocity. The formula is u sine theta, and that is 40 sine 30, and that's equals to 20 meter per second. The next question is final velocity, that is Vx, that is horizontal velocity after 2.5 seconds in air. That is the final velocity for the horizontal Vx, and that will equals to Vx will have the same formula as Ux, and that is u cos theta, and that's equals to 40 cos 30. Sorry, yes, 40 cos 30, and that's equals to what? 34.64 meter per second. And also, we also have to look for Vy. Our Vy will be equals to u sine theta minus gt, and that's equals to u, that is, our u is 40 sine 30 minus 10 times after 2.5 seconds in here, that is 2.5. Then our Vy would equals to minus 5 meter per second. So that is how to do it, guys. So we are now going to look for our Sx and Sy now. So guys, we will now talk about the horizontal distance after 2.5 seconds in air. That is Sx is equals to ut cos theta. Our u is 40, our t is 2.5 cos 30. Then we are going to get it as 86.6 meter per second. We will also look for our Sy, that is ut sine theta minus half gt squared, and that is equals to 40 times 2.5 sine 30 minus half times 10 times 2.5 squared. If you do the calculation very well, you are going to get 18.75 meter. Sorry, the unit of distance is meter rather. So that is that about the question, guys. In our next tutorial video, we are going to be talking about the 3 forms of projectile motion: the time of light, the range, the maximum height, the time taken, the total time taken. We are going to be talking about that. So make sure that in our next video, you do not miss out. So thank you for watching. Do not forget to comment if you have any question. Share with your friends and family. Thank you.